Hello students, welcome back to a new mathematics program for grade 8. Today we're going to talk about algebraic terms and algebraic expressions. Well, this video is the first of a series of 3 videos based on this chapter, that is algebraic terms and algebraic expressions. In this very first video, we're going to talk about HCF of algebraic terms, and in the last 2 videos we shall talk about factorization of algebraic expressions. So let's begin with how to find HCF of algebraic terms. So my dear friends, in this program you're going to learn how to find HCF of algebraic terms. But before going to HCF of algebraic terms, let's do a recap on certain things that you have learned in grade 7. Starting with how to write an integer as a product of its prime factors. For example, 16 as a product of its prime factors is same as 2 times 2 times 2 times 2. These 2's are the prime factors of 16. Similarly, for 36, as a product of its prime factors is 2 times 2 times 3 times 3. What about 110? Can you think about it? The product of its prime factors? Yes, it is, of course, 2 times 5 times 11. Students, you also learned how to write a number from index form to expanded form. That is, if we have a square, we can write it as a times a. A square b cubed c is same as a times b times b times b times c. Now look at this algebraic term. We have an integer value of 6, then we have algebraic terms p cubed q. So we can write the 6 as a product of its prime factors, that is 2 times 3. Then we write the p cubed q in expanded form, that is p times p times p times q. Students, you also learned how to find HCF of integers in grade 7. Remember that you have learned 2 different methods. The first method, using prime factorization. That is, you write the integers for which you want to find the HCF. You're going to write these integers as product of their prime factors. For example here, find the HCF of 18 and 24. First we write these 2 numbers, these 2 integers, as a product of their prime factors. So 18 is 2 times 3 times 3. 24 is 2 times 2 times 2 times 3. Now we want to find the HCF. HCF means highest common factor. Common factor. So we're going to look for the common factors of these 2 integers. These 2 common factors here are 2 and 3. Okay, as you can see, the other 2's are not common to 18 and 24, and the last 3 is not common to 24 and 18. So the HCF is 2 times 3 is equal to 6. You also learned how to find HCF of integers using index form. That is, we write the 2 integers for which we want to find the HCF as a product of their prime factors, but the prime factors are written in index form. That is, 18 is equal to 2 power 1 times 3 power 2, and 24 is 2 power 3 times 3 power 1. Now the HCF will be the least power of the common factors. Like here we have 2 is common to both 18 and 24. To find the HCF, we're going to take the number with the least power. The least power of 2 is 1, and the least power of 3 is 1. So the HCF is 2 power 1 times 3 power 1, which is equal to 6. Now we are going to use these 2 methods to find HCF of algebraic terms. Let's begin with the first method, that is using expanded form. The question here is find the HCF of AB and A square B. So first we write AB in expanded form, that is AB is equal to A times B, and A square B is equal to A times B. We are looking for the HCF, the highest common factor. Here, the common factors are A and B. So the HCF is A times B is equal to AB. We're going to find the HCF of the same terms, that is AB and A square B. Now we're going to use the second method, that is index form. So we're going to write AB as A power 1 times B power 1. And A square B is A power 2 times B power 1. Remember that in this method, we're going to take the common factors with the least power. Here the least power of A is 1 and the least power of B is also 1. So the HCF is A power 1 times B power 1, which is equal to AB. Let's look at another example. So we're going to find the HCF of AB cube, A square B square, now using the method of index form. So first we write AB cube as a product of its factors using index form. So AB cube is A power 1 times B power 3. And A square B square is equal to A square times B power 2, that is B square. To find the HCF of these two terms, we need to take the common factor having the least power. Here the least power of A is 1 and the least power of B is 2. So the HCF is A power 1 times B power 2, which is equal to AB square. Example 3. First we are going to use expanded form. Find the HCF of P q to the power of 3 r and P power 3 q r square. First we write these two terms in expanded form. Now tell me what will be the HCF. Of course, the HCF is taking the common factors. Here we have three common factors, that is P, Q and R. So the HCF is P times Q times R, which is PQR. Let's find the HCF of the same two algebraic terms now using the second method. Okay, so we are going to write these two algebraic terms as a product of their factors in index form. So PQ power 3R is equal to P power 1 times Q power 3 times R power 1. And P cube QR square is equal to P power 3 times Q power 1 times R power 2. So students, tell me what will be the HCF here. Yes, we're going to take the least power of P, Q and R. Here the least power of P is 1, the least power of Q is 1 and the least power of R is also 1. So the HCF is P power 1 times Q power 1 times R power 1, which is equal to PQR. Example 4. We are going to find the HCF of three algebraic terms now. You have seen how to find the HCF of two algebraic terms. Now we are having three algebraic terms. The methods remain the same. First, we are going to use expanded form. We write the three terms in expanded form. Then we find the common factors. Now tell me, what are the common factors? Yes, it is P, P again, and Q. So the HCF is P times Q is equal to P square Q. Let's find the HCF of these three terms now using the second method, that is index form. So we write the three terms as a product of the factors written in index form. What will be the HCF here? Yes, the HCF will be the common factors with the least power. What can you see here? The least power of P is 2 and the least power of Q is 1. But we have not taken R. Why? Because R is not common to the free terms. Okay, so R is not used in HCF because it is not a common factor to the free terms. So the HCF is B squared Q. Example 5. Now we're going to find HCF of these two algebraic terms. These two algebraic terms now contains integer values. So while writing 6ab cubed in expanded form, we need to write the integer value as a product of its prime factors, that is 2 times 3, and then we write ab cubed as a times b times b times b. Same for 10a squared b squared, which is equal to 2 times 5 times a times a times b times b. The HCF will be taking the common factors. So here the common factors are 2, a and b. B again, so the HCF is 2 times a times b times b, which is equal to 2ab squared. Now let's find the HCF of 6ab cubed and 10a squared b cubed using the method of index form. So first we write these two terms as a product of their factors written in index form. Okay, so now to find the HCF, we're going to take the common factors with the least power. Here the least power of 2 is 1, the least power of a is 1, and the least power of b is 2. So the HCF is 2 power 1 times a power 1 times b power 2 is equal to 2a power 1 b power 2. Okay, so we write it as 2ab squared as the answer. You will see here that we have not used the number 3 and the number 5, simply because 3 and 5 are not common to both the algebraic terms which we need to find the HCF. That is, 3 is not a common factor to 6 and 10, and 5 is not a common factor to 6 and 10. So the HCF of these two terms is 2ab squared. Another example, here we are having 3 algebraic terms, and in the 3 algebraic terms we do have an integer value and then the algebraic terms. So we write it in expanded form. This method, remember, is called finding HCF using the expanded form, and the HCF is taking the common factors. Here the common factors are p and q. So the HCF is p times q is equal to pq. As you can see here, we have not taken the integer values 2, 3 and 5 simply because they are not common to the 3 terms. We are going to find the HCF of the same 3 terms now using the second method, that is using index form. So we write these terms as a product of their factors written in index form. The HCF here will be taking the common factors with the least power. The common factors here are p and q, so the least power of p is 1 and the least power of q is also 1. So the HCF is pq. Now students, I'm giving you some exercises for practice. You're going to find the HCF of the following. If ever you are having any difficulties in finding the HCF, you can always seek the help of your parents or teachers. If you want to have some more information on this chapter, you can consult these websites. So friends, in this video, you have learned about HCF of algebraic terms. So students, this program ends here. In this video, you have learned how to calculate the HCF of algebraic terms. Remember that this video is the first part of a series of 3 videos based on the chapter Algebraic Terms and Algebraic Expressions. In this first video, you have learned how to calculate the HCF of algebraic terms. In the next two videos, you're going to learn how to factorize algebraic expressions. So see you soon for the next two videos. Till then, goodbye.